really important aspect of bringing these vehicles into sort of everyday life, a really important aspect of having them do these complicated missions is to recognize that a lot of the time these vehicles have to be operating where people are. They need to be taking instructions from people, working with people, collaborating to get things done. And bridging that gap between people and robots is a major research challenge for my group. You can't ask people to start changing how they behave and how they work with others. What you really want is robots that can interact with people as seamlessly as people work with each other. And so that's a challenge at a number of levels. One is you just got to think about the world the same way people do. You got to represent it in the same way. So we've been looking at things like semantic maps. Second thing is you got to understand what people want and how they behave. So we've been looking at understanding natural language, really connecting speech and words that people are using to things that the robot sees around it and things the robot can do. So for instance, we've had results in understanding directions, understanding instructions. Another part of that is how the robot can actually work with the human in terms of asking questions and improving its own understanding. So we've done a certain amount of work in dialogue management where the human and the robot are really talking to each other and making sure that each one understands what the other is doing. And I think for robots operating in populated environments, this is a key technology that's got to mature substantially before we're really ready to have robots part of our everyday lives. The challenges from the robot side are not just how does it know it needs to ask a question, it's also got to ask the question in the right way that it's going to get an answer, a useful answer back from its human partner. You know, one of the standard failure modes for a dialogue system is where the robot or any autonomous dialogue system says, I don't understand. This is not useful. The human doesn't know how to help and is going to get annoyed and frustrated and abandon the robot really quickly. So even if the robot doesn't understand the UAV or the service robot or the self-driving car, even if it doesn't understand what it's supposed to do or it's missing a significant piece of information, it's got to know how to ask the right question in order to get a useful answer back and not drive the human partners nuts. So something I want to observe is that a key technology or a key capability that we've been relying on for many years in my group is the fact that a lot of the autonomy has got to be driven by data. So when we talk about human-robot interaction, we're really standing on large corpora of data that show how people and robots want to work together. In some cases, it's corpora we've collected ourselves. In other cases, there are corpora of interactions on the web that you can go and use and learn from. And so the combination of data and the combination of modern machine learning algorithms has really been hugely enabling for my group. Whether it's learning new capabilities for the robot, learning how I made reference to trying to understand how wind patterns can affect the vehicle, or machine learning techniques to drive that. Computation's gotten faster, machine learning algorithms gotten better, and the data is now available that really is enabling the next generation of vehicle autonomy.